Okay, this is our number 3, and it is saying to a cyclist riding due north at 40 kilometers per hour. A steady wind appears to blow from west at 30 kilometers per hour. This is a different question from what we've been looking at because we are having appears to blow from. The moment you see appears to blow from, it means it's leaving this direction, going to another direction. So if it is blowing from west, then it is going to east. All right, now here our summary of the table would be velocity of the cyclist. We shall have vector, shall have direction, we shall have the magnitude. The vector is, shall have velocity of the cyclist, which is direction north. Magnitude is 40 kilometers per hour. Then we have velocity of wind. We don't know it because they need it. They need actual velocity of the wind. So we don't know the direction of the wind. We don't know its magnitude of the velocity. But when they say the wind appears to blow from, it means that this is the velocity of the wind relative to the cyclist. If they say wind appears to blow from, so it is wind relative to the cyclist. So the magnitude is 30. Sorry, the direction, since it is moving from west, then the direction is east because it is leaving west going to east, and the magnitude is 30 kilometers per hour. So that is what we have. We can do simple sketches, or from here, we can just see. So from the table, velocity of a cyclist, we are saying that is due north. So it means that velocity of a cyclist is 40 J. And the velocity of wind relative to cyclist is going east at 30. So the velocity of wind relative to the cyclist is 30 I. Implying that here you can really see from this, but velocity of wind relative to the cyclist, the same as velocity of wind minus velocity of the cyclist. Implying that if we are interested in velocity of wind, it's the same as plus the velocity of the cyclist. So velocity of wind is equal to relative velocity of wind to the cyclist, that is 30I, plus velocity of the cyclist, that is 40J. This is the velocity of the wind, but we need its magnitude. So velocity of wind is the root of 30 squared plus 40 squared. Same as the root of 900 plus 1,600. And this one will give us the velocity of the wind as square root of that, shall get 50 kilometers per hour. But then that is the velocity of the wind, so we also need its direction. So the direction, we have positive 30, first sketch positive 30, and then positive J. You can do like this, then positive. So this is 40, this is 30. Then we look for the, shall look for the angle theta, and we shall use tan. So our tan theta will be going to opposite. Now our opposite will be 30 out of 40, which is 3 out of 4. So theta is tan inverse of 3 out of 4. And this gives 36.9 degrees. Then you conclude. You're going to conclude and say, therefore, the true velocity of the wind is 50 kilometers per hour in the direction, you first mentioned the J component, in the direction north, 36.9 degrees east. That is how the question would be. Okay, now from here, let's do some other question to deepen our understanding about this. Question 4. A motorist traveling due north at 40 kilometers per hour a steady wind appears to blow from north 60 degrees east at 50 kilometers per hour. Roman 1, find the true velocity of the wind find the true velocity of the wind. Roman 2, if the wind velocity remains constant, but the speed of a motorist is increasing, find his speed when the wind appears to be blowing from the direction north 45 degrees east. So that is the question. Let's see how it is done. Okay, so now here is our question, and let's really see how we can go about it to a motorist traveling due north. A simple summary of the question can help us understand the question very well. We are having the vector, we are having direction of that vector, and then the magnitude. Now, so we have a motorist. I can still call him VC for the motorist. Direction is north. Velocity 40 kilometers per hour. Then I have wind. I don't know its direction, and I don't know the magnitude. Then they're saying that the wind appears to blow from north 60 degrees east. Now, to know the direction, of course, we say that if they say appears to blow from, that is the relative velocity. So we shall have velocity of the wind relative to the cyclist. The wind appears to blow from, that is the relative velocity. Now, if they say from north 60 degrees east, if you want to know now the real velocity, first sketch it like here. If this is northeast, this is north, then it's so northeast is this. So what would be the direction of the wind? It will be southwest. But to be specific here, you can say from north 60 degrees east. The sketch will give you the clue very well. Then at which speed? 50 kilometers per hour. Now, after having interpreted the question, then now you sketch. And of which sketching, I told you that what makes this approach easier is that you just apply the basics. Now, from the table, you can see that velocity of a cyclist, this is moving due north at 40 kilometers per hour. It means that the velocity of a cyclist is 40 J. Then now we sketch for this part. Appears to blow from, so velocity of wind relative to the cyclist or the motorist. It appears to blow from. So if you have your north, this is my east, this is my north. Meaning it was supposed to be blowing, northeast is this, okay? Northeast is this, but it is appearing to blow from there. So if it appears to blow from northeast, then it means that it is going this side of southwest. So that is how I would expect. So it is moving this side. It is leaving northeast. It is appearing to blow from northeast. So it is going from to this side. So this is 50. So now here you can resolve, and if this is my angle, 60 degrees, one can use a 30 and use this side up, but that is better. So this one is my course, and it is moving this side. It is leaving this side, going this side. So here, this will be 50 cos. I said where these two, the adjacent is resolved with respect to cos. So it is 50 cos. It is 50 cos 60 degrees. Then this one being the opposite will be 50 sine. 50 sine 60J. Meaning that from the diagram, you can say that velocity of wind relative to the cyclist is equal to, we begin by mentioning the I component. The I component is the one of this side, this direction of I, because I told you that we have I and J. So this side I, or the x-axis is I, the y-axis is J. So this one is what we call, you will say 50 sine 60I minus, because this is also in the negative, though the J, but in the negative. So minus, this is negative 50. Negative 50 sine 60I. Here we don't show the negatives on the diagram because the direction, the arrow shows already. So minus 50 cos 60J. Okay. So you compute on the calculator, you're going to get negative 43.5I minus cos 60 is a half. This was √3/2, so it reduces to this. Then 50 times a half, that is 25J. Now this is the velocity of wind relative to the cyclist, but velocity of wind relative to the cyclist, the same as velocity of wind minus velocity of the cyclist. So you can substitute. It implies that negative 43.5I minus 25J is equal to velocity of wind, which I don't have, minus velocity of the cyclist, which I have as 40J. Correct like terms. So it means that negative 43.5I minus 25J plus 40J is equals to velocity of wind. So velocity of wind will be equaling to negative 43.5I plus 15J. So now it is this that I'm going to get as the magnitude. So from here, members, let's go and look for the magnitude of that velocity. Magnitude of velocity of wind, magnitude will be equal to the square root of negative 43.5 squared plus 15 squared. And this will give you 46 kilometers per hour. 46 kilometers per hour. Then now to get the direction. To get direction, we are having the x component as negative. So you're having the negative component of x, that is 43.5, and the positive component of y. So you can move up, or you can do like this, and then you show me that it is a positive component, 15. Then you complete a triangle, then you get the required. So this is theta, and this is your magnitude, which you've gotten. So ideally, you can get the value of theta. So tan theta is equal to opposite 43.5 over adjacent 15. So theta will be the tan inverse of that, which will give you 70.9 degrees. And you have to conclude. You'll say, therefore, the velocity of the wind, actually, let me write this conclusion because I've already talked about it in words. So therefore, you'll say, therefore, the velocity of the wind the velocity of the wind is 46 kilometers per hour in the direction. The direction we first mentioned, the J component, so it is north. Then the angle 70.9 degrees. Then west. As simple as that. Then Roman 2. Roman 2, they are saying that if the wind velocity remains constant, but the speed of the motorist is increasing. You see, with mechanics, you have to interpret every statement. The wind velocity is constant. But the speed of the motorist is increasing. Find the speed when the wind appears to be blowing from north 45 degrees east. Very interesting question. So here we shall have vector again. If I'm to simplify that statement, vector, we shall have direction, and we shall have magnitude. Velocity of a cyclist. They are saying that if the wind velocity remains constant, but the speed of the motorist is increasing, but still in the same direction, of course. If he's moving north, his speed increasing will not take him to south. No, he will keep moving north. but I don't know his speed, because they want us to get his speed when the velocity, when the wind is increasing, when the wind now is appearing to be blowing from that direction given. So velocity of the wind is given. We've gotten it. Okay, we have it 43.5 I plus 15 J. So we already have the velocity of the wind, and we don't, the magnitude, we shall specifically use this velocity. Then wind relative to the cyclist is now been given from north 45 degrees east. But they have not given the magnitude. So let me let the magnitude to be Y. Okay. You go through the question again and retrieve it very much better. You're going to find out that my reasoning here is worth. The velocity of the wind has not changed, meaning what we've gotten is that. Okay. But the cyclist speed is increasing, but he was in north, so the speed is increasing while in that direction. But then they want us to find the velocity of that cyclist if the wind is appearing to blow from north 45 degrees east. Now, from this table, you can see that the velocity of the cyclist or velocity of the motorist is xc, j, because it's moving in the north. Now, let's look at velocity of wind relative to the cyclist, and that is by sketching. So, since this is my north, and this is my east. So the motorist is appearing to blow from north 45 degrees east, so he's coming this side still. Uh, 45 degrees. So we have not been given the magnitude. I rate it to be y, implying that here you will have y cos 45 degrees, and here you will have y sin 45 degrees. Isn't it? Meaning that velocity, this would mean that velocity of wind relative to the cyclist is, we begin by mentioning the I component, but it is in the negative, so it will be negative y sin 45 degrees, then minus, because this is also in negative, y, this is I, cos 45 degrees, then j. Now, velocity of wind relative to the cyclist is the same as, it will be negative y. Sin 45 is root 2 over 2. So root 2 out of 2i. Even cos 45 is the same. So minus y root 2 out of 2j. But you need to know that velocity of wind relative to the cyclist, the same as velocity of wind minus velocity of the cyclist. Okay? Meaning that velocity of wind is equal to wind relative to the cyclist plus velocity of the cyclist. Okay? Now, velocity of wind is going to be equal to velocity of wind and that cyclist, it will be y root 2 out of 2I minus y root 2 out of 2j plus velocity of a cyclist, which is xj. So we can correct like terms. So it implies that this is going to be minus y root 2 over 2I plus x minus y root 2 out of 2j. This is velocity of wind. But remember, they told us that the velocity of the wind remained constant, and we already have it. It was 43.5I plus 15j. But velocity of wind is equals to 43.5I negative plus 15j. So we shall equate, implying that if I go this side, I will have negative y root 2 out of 2I plus x minus y root 2 out of 2j equaling to negative 43.5I plus 15j. So equate corresponding unit vectors. So for I, it would mean that negative y root 2 out of 2 is equals to 43.5. This will give you your y as times 2 over root 2. It will give you y as 87 out of root 2. Then when we go for j component, we shall have x minus y root 2 over 2 equaling to 15, implying that x minus 87 root 2 times root 2 over 2 is equaling to 15. All right, so this one will cancel, and we shall have x minus 43.5 equaling to 15, giving us our x as 58, okay, 0.5 kilometers per hour. Therefore, the speed of the motorist is 58.5 kilometers per hour. The direction, no need, because the direction was already given. From our table, we have that velocity of c, the direction north, magnitude x. So by getting x, we are done. The direction is still north. So that is how the question was supposed to be. Enjoyable. Done. Let me do one more example for you. Let me do one more example for you. And we see. This example goes, a cyclist riding due north at 40 kilometers per hour. A steady wind appears to blow eastwards. Appears to blow eastwards, not from, to blow eastwards. On reducing his speed, to 30 kilometers per hour, The wind appears to come from southwest. Find the true velocity of the wind. That is the question. Very easy, because I think a cyclist riding due north. Let's first summarize the first case. We have vector, we have direction, we have magnitude. That is for the first case. We have velocity of the cyclist, direction north, speed 40. Velocity of wind, we don't know it. We don't know its magnitude. It appears, they say, the wind appears to blow eastwards. So that is the velocity of the wind relative to the cyclist, appearing to blow eastwards. At which speed? We don't know it. We don't know it. That is the first case. But then they are saying that on reducing his speed, that is another case now. Let me call this one case 1. I call this one case 2. We have vector, we have direction, and the magnitude. On reducing his speed, so velocity of the cyclist still is in north, but he has reduced his speed now to 30 kilometers per hour. Velocity of the wind, we don't know. Its magnitude, we don't know. But the wind appears to blow from southwest. Which magnitude? We don't know. So they want us to find the true. They want us to find the true velocity of the wind. True velocity of the wind. So let's first work on table 1. Let's first summarize from the table 1. From table 1, velocity of a cyclist is equal to 40 north, so it is 40I, and velocity of wind relative to the cyclist, x east, so it is xi. Meaning that, but velocity of wind relative to the cyclist is the same as velocity of wind minus velocity of cyclist, right? So velocity of wind is equal to WVC plus velocity of the cyclist. So it is going to be our velocity of wind, we are going to get it as xi plus 40j. This 40j because it is north, 40j. I call this one my equation 1. From table 1, I've got an equation 1. Then for table 2, for table 2, I can even summarize the way I've done this. The motorist reduced the speed to 30 kilometers per hour. So the velocity of a cyclist is 30, but because of north, j. Then the wind appears to blow from southwest. So draw the components. This is east, this is north, of course, this is west, and this is south. So if it is appearing to blow from southwest, southwest is this. So it means it is going to northeast. But we say that the magnitude is y. If it is northwest, what, provided it is northwest, southwest, southeast, just the angle there is 45 degrees. Unless they have specified, for other angles they specify. So we shall have the components, meaning that here, being the adjacent, we shall have y cos 45 degrees, and there we shall have y sin 45 degrees. So the velocity, this is for the case of wind relative to the cyclist. So velocity of wind relative to the cyclist will be equaling to, we begin with I component, that is y cos 45i, plus the j component, that is y sin 45j. Right. So looking at all this, looking at this, we can get an equation from here. We can get an equation from here. Let me write it here. Velocity of wind relative to the cyclist is going to be y cos 45, that is √2/2i, plus y √2/2, then j. So from here still, we are going to equate. We are going to equate still from here, because we know that this is the velocity of wind minus velocity of the cyclist. So we are moving with this equation, and from this equation also we are going to bring in the VC, so that we get another velocity of wind. Then we equate these velocities of wind and we get what is required. So from velocity of wind relative to the cyclist, which was equal to, it was y √2/2i plus y √2/2j. It would mean that, don't forget, velocity of wind relative to the cyclist is the same as velocity of wind minus velocity of the cyclist. So velocity of wind will be equal to wind relative to c plus velocity of a cyclist. So my velocity of wind is going to be equal to velocity of wind, which is y √2/2i plus y √2/2j, then plus velocity of the cyclist, which was 30j. When you factorize out well, our velocity of wind is going to be y √2/2i plus the j components, y √2/2 plus 30, then j. So that is my equation 2. Equate equation 2 and equation 1. So equate, because they are all velocities of wind, equate 1 and 2. So it would mean that from equation 1, which was xi plus 40j is equal to y √2/2i plus y √2/2 plus 30j. So equate I components together and j components together. So for I, you see that x this side is equal to, our x is going to be y √2/2. All right. Yeah. Then for j, we are going to see that 40, this side we have 40, is equal to y √2/2 plus 30. So you can see that 10 is equals to y root 2 over 2. And your y will be going to 20 over root 2. So if y is equals to 20 over root 2, then from this one here, it would mean that our x will be equaling to 20 root 2 times root 2 over 2, which is going to be, I've just substituted here with y. So I will get 10. My x is 10. Okay, my x is 10. And here you can see y over root 2. So you can multiply root 2 up and root 2 up. So this one can really be rationalized, because if we have gotten x, then we can also get y. So it is going to be 20 root 2 over 2, which is 10 root 2. So it means that the velocity of wind is 10 root 2I plus 10J, because it was, oh no, it is XI plus 40J. So our X is 10. So it is 10I plus 40J. Then we get the magnitude. Velocity of wind is equal to the square root of 10 squared plus 40 squared. And you get your velocity of wind as 41.231 kilometers per hour. And from this, you can really get the magnitude. Okay, you can get the magnitude because you already have the component 10I plus 40J. So you can get we've gotten the magnitude, so you can get the direction. Sorry, you can get the direction, and which direction is going to be since you had 10I, so it will be 10I, that is 10I here, and the positive 40J. So you can do like this. This is 10, this is 40. You get theta. All right. So you can get tan theta is equals to 10 out of 40, and you get your theta as 14 degrees. Then you conclude the true velocity of the wind is 41.231 kilometers per hour in the direction north 14 degrees east. As simple as that. Get all your marks. So that is all about that's all about relative velocity. That's all about relative velocity. Now, next video, we are going to look at the relative path. Then we shall also look at the shortest distance. Okay, distance of closest approach. Then the collisions, and then we progress. I wish you all the best. Thank you for listening.